Storage of data. Okay. How it is implemented? Do you have any idea? Maybe yesterday I already told how hard disk they have implemented. Okay, how you can store the data. To get the data from this, what and all address information you need to send. That is track number, sector number you need to send. The read write data to move to the particular track and sector. Then only it will be able to read the required information. So that is in case of secondary storage. So it is going to be totally different. How the data stored in secondary storage and how the data stored in main memory and cache memory, it is totally different. And also whenever the CPU generated address, it is related to the main memory address. Okay, that is called a physical address. It is not the address that can be referred in the hard disk. No. Always, whatever the address it is going to generate, that is with respect to main memory, not even cache memory. So to make match with the data, whatever the address that is generated by the CPU, so it should match even for the cache memory. For that, it requires some technique should be used for conversion of the address. Okay, so we'll discuss that part later. Let's move on to the semiconductor memory. So yesterday we have already discussed all these basic things. Okay, so I think I've stopped here. So now three categories of RAM. Okay, so in that not three categories, only two categories. One is static RAM and another one is dynamic RAM. So what is the advantage of each of these methods? So each one of it is having its own advantage and disadvantage, SRAM and DRAM. Accordingly, so based on what are the features it is supported by SRAM, so you're going to plan to use that particular RAM in the memory hierarchy. Okay, so SRAM, it is most of the time it is used for implementing cache memory. Okay, so what is the expectation in the cache memory? So we want the data to be fetched at faster rate compared to main memory. Always the data should be fetched from the cache memory at very fast. Okay, and SRAM, the cost per bit to implement this cell, it is going to be very high compared to DRAM. Okay, so don't worry about the differences. We'll discuss the difference later. First, just understand. So both are volatile memory, but depending on the requirement, if it is if it is too high, okay, so then we need to go for implementing the small size of the memory, that is example cache memory. Okay, if the cost is compared to SRAM, if it is less, then we are going to use DRAM in case of main memory. Okay, so that is how depending on the requirement. Because why can't we use, because SRAM is too fast, why can't we use SRAM to implement the main memory? We cannot use that because the cost per bit, it is going to be too costly in case of SRAM. So what is the meaning of cost per bit? It indicates, say, all the data that is stored in the memory, in main memory, it is in the form of arrays of cells. Okay, so each cell, it is capable of storing one bit information. Okay, I will just tell what is this rows indicates, what is this column, so that we are going to discuss in detail. So here this bit we call it, this cell we call it as one bit information. This cell is capable of storing one bit information. So like that, some set of cells you are going to implement in row wise. Okay, so that forms the word. So we'll discuss that how word is going to be activated, because how it is going to match with the address depending on the circuit. Okay, just remember here, it is a semiconductor material. So in that, so each cell represents one bit information. Either the bit information can be 1 or a 0. Okay, and this data can hold this data as long as the power is on. Once power goes off, whatever the data that is stored in this memory, it is going to be erased. Okay, so that's all about the RAM. So in that, so we'll just go with a very specific category, that is SRAM and DRAM. So before going to either SRAM or DRAM, so we'll just look into the general structure, how memory is organized. Okay. So if you have observed in your system, so it is not just a single chip of the memory. Okay. So always whenever you take RAM, I think I have a diagram here. Can you see, it will be having multiple chips connected. So you just check it in your system, you will be having a slot for RAM. So either it can be 2 GB or 4 GB. So it is not only having only one memory chip, it will be having set of memory chips. Okay, so in this case, whenever if address comes, how it is going to select. Okay, so all that question arises, we'll just discuss that part. So this is just one image that indicates how the RAM look like. Okay, so here each memory cell can hold 1 bit information. What is cell here? So whatever I have represented here is row and columns. So in that case, this particular cell is capable of holding 1 bit information. Okay. Now what is the challenge, or what you need to understand here it is how they have implemented the cell here. Okay. I am not going to explain all 2 GB of RAM. If you understand one particular cell, how it works, what is the circuit diagram they have used, okay, then it is applicable for all the remaining cells. Okay, the same circuit it is used for implementing another bit information, then next bit, like that. Okay, it will be having set of bit information that is capable of storing only 1 bit information. That is, each cell it is capable of storing 1 bit information, and each of these cells are organized in the form of array, that is in the form of sequence. Okay, so this is, if you take multi-dimensional array, okay, this is one array, the first row of the array, then second, third, fourth, and so on. Okay, so depending on the size, you are going to implement the memory. And one row, can you see here? So this one cell, it is going to store 1 bit information, and this row indicates the word. So we are already familiar with what is word. Yes, no? What is word? Set of bytes. Okay, depending on which computer system you are going to use, is it 32-bit or 64-bit? Accordingly, you can specify the word length. So here we are just discussing 32-bit word length. So here you will be having 32 cells organized in each row to form a word. So like that, it can have a number of words, okay, in the memory. So now we have already discussed in IO organization. So whenever the address is placed on the address bus, so it has to, whichever the device that matches with the address, it has to recognize. So here we are not discussing with respect to IO device, it is with respect to the memory. When it comes to the memory, so whichever the address that comes on the address bus, okay, so that address is taken and it is going to try to match. Okay, so it is going to try to match the address. Is it belongs to this address or this address? So accordingly, that particular cell, it is going, that particular word is going to get activated. Okay, whichever the word it is get activated, so either you are going to perform read or write operation. Read means whatever the cell, so if this line is activated, so whatever the cell information it contains at the bit 0 or 1, so it is going to just read that information sent to the data lines. Okay, it will be sent to the data lines. From data line, it will be sent to the processor. If it is write operation, so whatever the data that comes from the output lines, okay, from the data line, that will be placed onto the whichever the word or whichever the line that is get activated. So that information from data line, it will be placed onto the word. Okay, so that is how the cells are organized for storing the information. So here whatever I am going to explain, that is with respect to cell. So this is how the complete memory is designed. So there is a specific size of the memory, that also we will discuss, how many rows and how many columns it will be there. So here just understand, so the memory system, it is organized in the form of set of arrays, and each in the array, each cell it is going to capable of holding 1 bit information. Okay, and we are going to discuss more focus on the microscopic level. Okay, so more focus on how this cell is implemented. Either it may be SRAM or DRAM. We are going to look into the cell. So how that cell is implemented and how it works. And also after learning that, you will be able to compare so SRAM and DRAM, and you will be able to tell what is the difference between these two in terms of size, speed, okay, in terms of complexity, all those things. So after that word line, so here it requires one more special control line called sense or write circuit. Okay, so I think I'll just go to the diagram. Is it diagram is visible? Okay, so now where is the address decoder? Where it will be there? It will be there in the interface. Okay, So interface, that is one of the important functionality. So address decoder, as soon as address is placed on the address line, so it is going to start decoding the address. Okay. Once it decodes the address, it will come to know that which row should be activated. Which row should be activated. How many rows are available here? Observe the diagram. W0 to W50. That means total 60 words. And each row contains how many bits? Check it. It is numbered just 0 to 7. That means 1 byte information. That is 8 bits. So that is 16 into 8 memory organization. So whatever the diagram you are looking, so the configuration of this diagram, it is 16 cross 8. So 16 indicates number of rows, that is nothing but number of words. Okay, 8 indicates in each column, I mean there are 8 bits in column wise. Okay, so you can just see, this is, you can see two values. It is just one number, one bit it is going to indicate. So the two lines indicates either the bit value is 0 or 1. Okay, for that reason, so we are representing with two numbers here, 7. So 0 to 7, that is the word length. That means one byte is equal to one word. That is only just assumption. If they ask for 2 words, I mean 2 bytes, then it is going to increase. That is going to be 16 cross 16. So now tell me how many number of cells are there here according to this configuration? 128 cells. That means the total memory it can hold 128 bits. Okay, it is too small. Okay, it is too small. Just for understanding purpose, I have taken this diagram. Okay, so now the total size of this diagram, not this one. So the size of this memory is 128 bits. It is capable of holding 128 bit information. Okay, so now just observe. So address, so that is A0 to A3. So how many bits? 4. So yesterday we have discussed depending on number of bits in the address, you can tell how many number of addressable location. 2 power 4. 2 power 4 means 16. So do you have 16 addressable locations? Yes, no, you can just observe W0 to W1. So each word indicate the one addressable location. Okay, so W0 indicates the first row, then second row up to so on. There are 16 rows. So that means by knowing the number of bits in the address, you can tell how many number of addressable locations. So this we have already discussed. Any doubt in this? So here number of bits are 4. So 2 power 4 is 16. That means now I can have 2 power 14, that is 16 addressable locations. That is W0 to W15. Clear? So now in additional to this, you can just observe. So how they have implemented this cell? So here cell is nothing but it can be a flip-flop. Have you heard flip-flop? What it is going to perform? On and off. That means it can hold 1 bit information. Okay. So here also they have implemented a cell that is capable of holding 1 bit information. I think you can just see here FF indicates flip-flop. Either it can be a flip-flop or it can be a latch where it will be capable of holding 1 bit information. Okay, so that's all about this circuit diagram, and there are some more information with respect to the circuit diagram, that is sense write circuit. Okay, so this is going to sense the data, whatever, either it may be input or output. Okay, it will sense the data and the data will be transferred. If it is read operation, whichever the line, whichever the row is activated, it will read the data and it will be placed onto the output lines. If it is write operation, whatever the data that comes from the data line, so that will be placed into the corresponding whichever the line here it is activated, it is going to store that value into the corresponding row. See how the operation is going to take place here. Like what is the first step for read or write? Okay, for yes, the first step is whenever address comes, first step is it has to activate any one of the word line. Okay, the row should be get activated, any one. Okay, if I have given the address 000, all 4 bits are 00. Okay, then it is going to match with W0. Okay, only this row will get selected. Selected means it is going to be active. After that, okay, after that, if it is read operation, okay, so the corresponding bit information, it is going to read from this particular row and it will be sent to the data lines. Okay, so that is D7, okay, D6, D5. This dotted indicates you have there D6, D7, okay, not D7, D6, D5, D3, okay, it indicates and so on, okay, D7 to D0. So all the bits it is going to read and it will be placed onto the output lines. So the output lines are connected here. Okay, it is going to sense means whichever the line that is activated. So depending on what value it is stored in the cell, it will read the data and it will be sent to the output lines. Okay, so how many bits in the output line? It is 8 bits. That is nothing but 1 byte. Okay, it is going to read 1 byte of information at a time. In case you just assume, in case if your row contains more than 8 bits, in that case, what it will do? So here it is capable of reading only 7 bits. I don't want to change number of data lines. For that we have different technique. I'll explain that later. So now you can just see here there is one circuit that is going to recognize the control signal. When the address comes here, so the memory should know, no, is it read or write operation. So for that it requires to send the control signal. Okay, so that is read or write. So there is one more signal here, CS. What is this CS tells? So here CS indicates, yes, any idea? Chip select. It is not computer science, it is chip select. Okay, chip select means why chip select here? What is the meaning of chip? I told in RAM slot, you can see there are more than one chips. So among these chips, so in which chip you are going to perform read write operation? Okay, so accordingly it is going to select the chip number. Okay, then only it will be able to read or write the data. Okay, so this is for chip selection. That means, yes, so among set of multiple, Melvin, what you were doing? Okay, among set of chip, okay, so in which chip this address is going to belong? So that will be selected by chip select. Control signal, it is a control signal. Accordingly it will go to that particular chip and it will read the data. Okay, any doubt in this diagram? Just try to understand, because we are going for the complex one next. Just go to the diagram, try to understand. If you have any doubt, ask me immediately. I didn't tell you to discuss. Just go through the diagram. If you have any doubt, you can ask me. See, normally if they ask either SRAM or DRAM to explain with a circuit diagram, okay, with a specified configuration, they will give the configuration, what size, accordingly you have to draw and you have to explain how read and write operation takes place. That's all. I am going to focus on only read and write operation. Thing is, here you need to understand whenever if cell is active, okay, how the read and write operation performs, you need to explain, and also some points with respect to what are the advantage and disadvantage of using that circuit diagram. Okay, is clear? I am not going to explain how flip-flop works, how inverter works. No, I am not going to do that. Anyhow, you are learning in ADE, so whenever it comes, you just go through that part and try to understand. Okay. Yes. So this diagram, is it clear? When I specify the organization 16 cross 8, what is the meaning? Everybody understood? Because next we are going for the higher number. So you just tell me the memory size. What do you mean by 1K? Yes. What do you mean by 1K? 1 kilobytes. What is the meaning of that? How many bytes? Yes. 2 power 10. 1k is nothing but 2 power 10. It is not 10 power 3. It is 10. It is 2 power 10. Okay. That means 1024. So 1024 what? 1024 bits, not bytes. It is bits. Okay. So I am just representing k. Okay, that is kilo. If it is mega, I will represent in terms of power of 2. 1 mega. No, 2 power 20. Okay. 1 giga, 2 power 30. 1 tera, 2 power 40. Okay. So you just be familiar with these things. Okay. So we'll be using the configuration of memory. Yes. So now we are going to move for another diagram. Yes. Just write on the circuit diagram. Quickly. Have you learned about multiplexer and demultiplexer? Okay, so my job is reduced. I won't explain how multiplexer and demultiplexer works. Okay. Whatever the basic concept you learned, the same thing apply here. Why you need to go for multiplexing and demultiplexing? What is the advantage? That is what you are telling the definition. What is the purpose of multiplexer? Why you are going for multiplexing the input? Find out why you need multiplexer and demultiplexer. To simplify equation. Okay, you are telling about theoretically, think practically why you need multiplexing and demultiplexing. Theoretically, okay for simplifying all of things. Is finished? If you stop your discussion and if you write, it will complete soon. Stop your discussion. See, This is 10-bit address. Make it fast. Finished. Yes. Now okay. Okay, stop writing. Listen here. Yes, stop your discussion. Listen here. Stop writing. So always whenever if you are analyzing any memory circuit diagram, first check how many number of bits they have given in the address. Check how many bits they have given. Number of bits in the address, it is 10. So 10 bits means what is the number of addressable location you are going to get? 2 per 10, that is nothing but 1024 addressable location. Okay, that is the memory configuration. Now you need to understand how those addresses are used and it is going to perform read and write operation. Okay, now before going to the diagram, observe here, I told always whenever if it want to perform any read write operation, it has to activate the row first. Okay, row is nothing but word. Consider if this is the row address it is matching, so it has to activate this. Then followed by, it has to activate the bit line. Can you see here these columns? Okay, so it indicates the column. Okay, bit line. So whichever the bit that is 0 or 1, accordingly it is going to set the bit information in that particular row. Okay, so accordingly, if it is read operation, it will just read whichever the row that is activated and whatever the information it is stored in the cell, it will read and it will send to the data lines. Okay, the input lines and also output lines. So here they are going to use both input and output same data lines. Is it required to use separate data lines? Not required. So at any time you are going to perform either read or write operation with respect to memory. Okay, the same data lines you can use for read or write. So now whichever the row it is selected, okay, so whatever the value it is present in that cell, it will be sent to the data line, input data line for read operation. If it is write operation, first it will take the address, it will find out to which location it is matching, accordingly it will activate the row address and also whatever the data that is coming from the output line. Okay, so if the processor want to write some data, so that it is going to send through the output lines. So now those output lines, that is B0 to B7, get activated. Okay, and that is going to transfer the information to these cells. Either it is B0 or B1, I mean 0 or 1. So it is going to affect only that particular row that is activated. So that is how the data it is going to stored in each cell. So now coming to this diagram, you can just observe there is little bit change in the diagram, that is with respect to the address. How they are going to use the 10-bit address to identify the row address and column address. Okay, so now among these 10 bits, 5 bits are used for row address and remaining 5 bits it is used for column address. Okay, and when the row address comes here to the decoder, it is going to decode the address. So decode the address it is nothing but it will take that address and it will try to match. It is going to match or it is going to find out to which line it has to activate. Okay, so is it W0 or W1? So whatever the address it comes, it is going to activate the corresponding row. Okay, that is the first step. That particular row get activated. Afterwards, it will take the remaining 5 bits. Okay, that is used for identifying the column address. Okay, the column address is nothing but the bit line. See, just selecting row it is not enough. Even it requires to activate the corresponding bit line. So for that you are going to use the remaining 5-bit address. Okay, so those 5-bit address it is connected to this memory cell. Accordingly, it will perform the either read or write operation. So you can just see here there is a sense or write circuit. So that is going to perform the sensing of the value that is stored in the cell. Okay, it will sense the value that is stored in the cell and that will be transferred to either input or output line. So in between you can just check it here. They are going to use the multiplexer, output multiplexer and input demultiplexer. Okay, so how multiplexer works you already know. So the main purpose of going for multiplexing and demultiplexing is to reduce the number of lines. That means the wires. Okay, so for that purpose we are going to use multiplexer and demultiplexer. Don't analyze too much like how multiplexing is done here, all those things. Just understand how they have designed this circuit diagram. Okay, so that is just to reduce the number of lines. So lines is nothing but the bit line, it can be reduced. So accordingly, so we have control signal. Based on the control signal, it will perform read or write and also chip select. So whenever address comes, along with that, it will indicate is it the first memory chip or second memory chip accordingly. So it is going to activate the memory chip. Okay, so you just observe, remember this diagram. You can see there are so many chips, memory chips are attached. Among these, that address belongs to which chip. So accordingly, it is going to perform the read and write operation. First step is always chip select. It has to select among multiple set of chips. First, it has to select the chip. Then only it can perform the read and write operation. Okay, so that is just the simple memory, internal memory organization for 1K cross 1. And you can just observe here. So how it is not like 1024 bits rows we have. So now 1024 bits are organized in the form of 32 cross 32. 32 cross 32. What is the value you get? Yes? What is the value you will get? 1024. Okay? It is nothing but representing the 1024. That means you have number of rows is W0 to W31. Okay? So that is you have 32 rows and 32 columns. But here I told you have only the number of output lines. It is only B0 to B7. Then how you can read 32 bits? I mean, 32 bits, nothing but 4 bytes. So in that case, it is going to use a technique where it will keep the address constant, okay, and it will change only the column address and it will read the corresponding byte in the same row. Yes, understood this diagram, everyone? Girls? Boys, last bench, others, stand up. Yes, we'll move on to next diagram, that is SRAM. Just note down static RAM. So now we are going to deal with particular cell, how the RAM cell is implemented. This particular cell we are going to discuss, not the complete memory organization. Later we'll go to the complete memory organization for the given size. Will you note down this diagram quickly? So here what is static memory? So static memory indicates memory consists of circuits capable of retaining their state as long as power is applied. We are already familiar with this, but we have not discussed what is static and what is dynamic. Everybody knows about RAM, but what is SRAM and DRAM? We need to understand. So now that variation they have given based on the circuit implementation. Okay, how the circuit is implemented. So now we'll just go to this diagram. You can just observe here. we have two inverters and there are two transistors. Two inverters and two transistors. So now, just quickly take this diagram. I'll explain how read and write operation performs. So many times they asked SRAM and DRAM. You have to draw the cell diagram and you have to explain how read write operation takes place. So here you need to remember how many transistors we are using to implement. So here mainly two transistors and inverters are connected each other to form the flip-flop. Okay, that means to hold the 1-bit information. Okay, normally I can use the term flip-flop or latch where it will be able to hold 1-bit information. Okay, so this connection indicates it is a flip-flop for coding 1-bit information. Now you need to understand how this, can you observe here? The word line, that is nothing but the row and bit line. You can see it is negation B and B dash indicating. So the value may be either high or low, that is 1 or 0. So now, so how read operation takes place? Okay, the read operation takes place in this manner, that is word line is activated to close switch T1 and T2. So you need to understand, I already told, always whenever it comes for either read or write operation, okay, first it has to activate the word line. Okay, first activate the word line. That's what I'm explaining how it is done. It is word line is activated by closing the switch of T1 and T2. Okay, closing the switch of T1, that is transistor T1 and T2. So it will enter into any one of these states. So that is state 1 indicates the signal on bit line is high and the signal on bit line B dash is low. Obviously, if this is high, the negation is going to be the opposite of it. Okay, if it is high, it is going to be low. Okay, so that is whenever if this line is active, B is active and B dash is low, we can tell that the circuit is in the state 1. Okay, state 1. So it can be in state 0. When it will be in state 0? When it is in opposite of this. That is when B is low and B dash is high. So we call that state as state 0. Okay. So now what happens after activating the word line? So sense write circuit at the bottom of the monitor sees state of the bit line B and B dash and set the output accordingly. Okay. So here they have not given the sense write circuit that is connected to bit line. If you have observed in the previous diagram, can you see here it is connected the sense write circuit for the column or bit lines. Okay, it is going for sensing the value that is stored in B and B dash. Okay, that is the bit information column wise. Okay, so that is the function of sense write circuit. At the bottom monitors the state of B and B dash and set the output accordingly. Okay, so B and B dash, whatever the value it is set, accordingly it is going to these two lines once again connected to the output lines. Okay, so whatever the lines, the columns you can see, these internally connected to the output lines. So accordingly it is going to set the output. Output means on the data line what data it should send. It is 100 or whatever the value it is set according to that row, it will sense that value and it will set to the output lines. That is in case of read operation. If it is write operation, see always yesterday we have discussed to perform read and write what and all information the processor and memory has to share. Yes, no? Got it? Write operation. But here you just try to understand how write operation takes place with respect to this circuit diagram. Okay, mainly it requires address. Okay, what data to write? When it comes for write operation, the CPU want to write some data to the memory. In that case, even it requires data. So from where the data is going to come? So the data is going to come from the data lines. Okay. Now, once again, the same procedure you are going to use. That is, the state of the cell is set placing the value on the bit line and its complement value on B dash. That means first step is activate the word address. Okay. Then come to the column address, that is bit line. So depending on the whatever the output you are getting, the data you are getting from the output line, either is it 0 or 1, accordingly you are going to set the bit line. Okay. I am sending the data from data lines to the, I am storing into the memory. That is write operation. If it is 0011 something, so the same thing it is going to activate the bit line. If it is 0, it will make it low. If it is high, it will make it 1, the corresponding bit line. But it is applicable only for that row, whichever the row that is selected. Okay. So that is about the static RAM. So if they ask explain SRAM with a neat diagram, then you have to draw this diagram. Okay, just tell about the transistor and the inverter used for forming the flip-flop. Then just explain how read and write operation takes place. So next we'll move on to asynchronous DRAM. Yes, asynchronous DRAM. So I think we are already familiar with synchronous and asynchronous. What do you mean by? What is the difference? Synchronous, I am asking about the keywords, not DRAM. Synchronous and asynchronous. We have discussed the same thing in bus structure. Where? In synchronous, where you are going to use the common clock. In case of asynchronous, you are going to use the handshake protocol. That is, you are going to use control signals to make communication or to extend the data. Okay, instead of using the clock time information to perform read write, you are going to use the clock signal, not clock signals, control signals. Okay, so now the same thing happens here. What is the time? Okay, I want to give the quiz, so we'll discuss the remaining in the next class. Okay, synchronous and dynamic memory, asynchronous.